Hi, welcome to today's lesson on percent change. Okay, so we're going to be looking at percent increases and decreases and how to calculate them. Now, there's a lot of application of why you want to know what the percent change is, and we're going to get into some very specifics in the next video on markups and discounts, and that's going to be anytime you're buying and selling. Okay, so we'll talk about those a little bit later. But really, when we want to talk about things like maybe population change in light of all of the wonderfulness of the COVID, what's the percent of something we look at called the infection rate? What's the percent of the people that they check that have the disease? What is the percent change then from, let's say, last month to this month? We want to be able to calculate that, and that has an impact maybe on the policies that they're trying to employ, all kinds of things. So there's all kinds of reasons for wanting to know percent changes. And it's very important because I always love, if you watch, sometimes they do this on commercials and they'll tell you, this is 95% effective. And it's like, well, it drops it from like 1 to, if it drops it from 100 to 5, that's a big change, right? That's a 95%. But if it drops it from like 1 to 0.05, it's the same percentage. It's just not nearly as impactful as other things. This is also a fun way to use statistical values to really sort of paint a different picture than what the truth is. So let's take a look at how we do that. Okay. So here we're even going to start out with a problem very near and dear to my heart. Okay. It says a middle school has an enrollment drop from 225 to 180. What is the percent decrease? Now, the reason I say that's near and dear to my heart is I was at a school where the enrollment dropped, and as a result, I had to find a different school to work at because I was one of the new teachers at that school, and that forced me to end up at a different school, which actually brought me to where I am today. So I don't look at it as a bad thing. I just look at it as an important part of something that made a huge impact on my life was this question right here. So how do we do that? Okay. In order to find the percent change, we need a value that is not actually there yet. Okay, we're going to set up this following proportion, and the big value that we really need to talk about is right here: the amount of the change. How much did, in this case, how much did the enrollment change from, let's say, one year to the next, whatever year this was? So very, very important to be aware of how much it changed. Okay, so it's not enough to you can't just grab these two numbers and go. Okay, what you would be finding then would be how much of the one enrollment is a percent of the old enrollment, but we don't want to know that. We want to know what the percent of the change was. So it's very different. So we need this number right here, the amount of the change. That is the most important aspect of this, and we're going to talk a lot about that in class and in this video. Okay, and then we put it over the starting number. Where did we start? Did we go up? Did we go down? No, we already knew because we were asked in the question that it was a percent decrease. And, it's pretty clear. We can see if it goes from 225 to 180, it's going down. So we know that. But I want to point something out about percent decreases here that really also is important to all of the work we're going to do. Percent decrease cannot exceed 100. If you go from a number down to 0, that is a 100% decrease. Okay, unless you have a way to go to negatives, it's gone. It's 100% decreased. Okay, now I guess you could have more than 100% if you were talking about temperatures. You could go down into the negative temperatures. But in almost every other aspect you're going to see this in, 100% is the end of the decrease because it's gone, whatever it is. Population, number of students, people who need to get vaccinated, people who have the disease, all those things, once they go to 0, it's over. They're done. They're gone. Okay? And that equals, we're looking for a percent. Anytime we're looking for a percent means per out of cent, 100. So it's always going to be out of 100. That's not going to change. Notice there's no descriptor over there. It's just x over 100 because it's going to be that. Every time we're looking for a percent change, we're going to look for an x over 100. So now we have to plug the numbers in. The 220, and the nice thing here is we're always going to take the big number minus the small number. This is almost like back in elementary school, where you always want the big number minus the small number. Now, this isn't always the case. We can have negatives, but not in this case. In this case, we're always going to do the biggest number minus the smallest number. So 225 minus 180. That gets us how much the enrollment changed, up or down. We didn't, we were already told it was down, but it tells us how much it changed. And then the other part is the starting number. So once we found the amount that it changed, we don't need this 180 ever again. It's done. It's done its job. It's told us what the amount that it changed was. Now we're only interested in where did we start from? 225. Okay, so how much did it change? Where did we start? And then we're back to solving a proportion. We've done this many, many times. If you need to look back at some previous videos, you're welcome to do so. Solving a proportion, absolutely on my list, because it keeps coming up. Why did we learn it way back when? Because it keeps coming up. There's so many applications of solving a proportion. So we cross multiply. 100 times 45 is 4,500. 225 times x is 225x. And then this is almost always the last step in solving any equation. There's so many times this comes up, and that is to divide both sides by the number, divide by the number next to the variable. We divide both sides by 225, and we get 20. And now we know, what is that 20? That is 20 out of 100. In other words, it's 20%. We were told it's a decrease, so we're going to include that as part of our answer, 20% decrease. So it was a 20% decrease in enrollment, and as a result, they needed 20% fewer teachers. And that was, I was one of those fewer teachers that they said, hey, you know what? But there's more kids over at this other school that was maybe having a percent increase. And it's what ended up sending me to the school that I'm at now, which is exactly the school I've always wanted to be at, honestly. Okay, it's the one closest to my home, and I couldn't be happier being at that school. So. Okay, all those things, that's to find their percent decrease in this case. And the nice thing is, and you're going to see in the next two examples, it doesn't matter if we're going up or down, increase or decrease, doesn't matter. The only thing that really kind of jumps out at me is what I just said. Decrease pretty much goes down to 100%. Once you've gotten more than 100%, your thing is gone. Now, there are ways to do it, but very few and very infrequently. But up, sky's the limit. There's nothing that says I can't go from I could buy something for $2 and make it $1,000, and that would be a very big percent increase. We'll talk about that when we get to markups and discounts in the next video. So let's take a look. From 40 to 50, and this is just how they're going to write it in most of the problems that they're asking, because that's really the simplest way. I want to know what the percent increase is from 40 to 50. Maybe this is a rise in the stock price. I don't know. Went from $40 a share to $50 a share. What's the percent increase? It's kind of nice to know, and they oftentimes talk about it that way. But the nice thing here is this is what we're going to do every single time. And you know me, I'm a big fan of if it works every time, use it. So we're going to go, even though it's 40 to 50, still we're doing the big number minus the small number, because we just want to know how much it changed. We're not concerning ourselves with whether it's up or down right now. We're just considering ourselves with how much it changed, the amount of the change. In this case, 10. And then our starting number, well, we went from 40. Pretty clear where we started. Started from 40. So 10 over 40 equals x over 100. Again, we cross multiply. 100 times 10 is 1,000. 40 times x is 40x. We divide both sides by 40, and we get that x is 25. And again, that's our percent. Now we can actually contemplate and just make sure we're sure of, hey, this is going from 40 to 50. I assume it's pretty clear that it is going up, and therefore it is a 25% increase. Okay, so we don't have to really, most of the stuff is pretty obvious. How much is it changing? 40 to 50, it's changing 10. Are we going up or down? We're going up. Okay, so now we just want to figure out exactly what that percentage is. Okay, now the last example should look very similar to the one we just did, and I have this one there because I really want to draw your attention to it, because I have students do this all the time. They get that, hey, 40 to 50 is a 25% increase. If I then say what's 50 to 40, they immediately want to just say it's the same thing but a decrease. And let me assure you, that is never the case. Never. And that's weird to say. Math does not have a lot of absolutes. but it doesn't work that way. Okay, it's not a percent increase and a percent decrease are the same. In fact, we're going to see that when we do the calculations. Everything's the same, right? 50 minus 40. The difference is, look where we started. Here we started at the number 40. Obviously, here we started at the number 50. So this number is changed. Okay, still 50 minus 40 is still 10, so the amount hasn't changed. We're still cross multiplying. We get 1,000, we get 50, but now we're dividing by 50. Here we divided by 40, here we're dividing by 50. We get a different percent change. This is a 20% decrease. So there's certainly no hard and fast rule that I want you to focus on when going up or going down. Don't try to, oh, well, if it's this going up, it must be that going down. Don't worry about that. This proportion works every single time. You plug in the numbers you know, how much did it change? Large number minus small number. Where did you start? Okay, doesn't matter. You know, sometimes you have to read the story to understand where you started, and up or down. Again, that should be clear to you when you look at it and say, hey, the number is going from 225 to 180. It's going down. It's going from 40 to 50. It's going up. 50 to 40. It's going down. That has to be just, observational. You just look, okay? But the process is the same every single time when you want to find percent change. You figure out what your amount of change is, divided by your starting number equals x over 100. And again, notice I didn't give you any kind of descriptors because it's always, if we're trying to find a percent, okay? And there are ways to work backwards from this that we're not really going to focus on right now. I'm sure you could see them if I said, hey, if I knew the starting number and I knew the percent change, I could figure out where we are now. If I knew the amount of the change and I knew the percentage, I could find the starting number. Anytime I get, any two of these three, I could figure out what the missing value was. Okay. So that's percent change. Now, in the next video that I'm going to be creating, and you're going to see it here, same cast, same shirt, everything, is going to be about markups and discounts. And then we're going to put a very specific label on it, which is to say we're going to really talk about money, and we're going to talk about when businesses buy and sell things. Okay, percent changes, lots of applications, times when we look at, like I said, again, with the coronavirus, infection rates and hospital rates and they're constantly throwing these numbers at us, and what do they represent? What's the percent increase, percent decrease? And sometimes those things can be deceptive. Okay, that's the last thing I'm going to say on that, because like I said, if you really want to know what I'm talking about, figure out what the percent increase from 2 to 3 is, and then decide if that's more or less important than, say, the percent increase from 2,000 to 2,100. Okay, one went up by one person, one went up by 100, but the percentages are nowhere near each other. Just something you might try for your own when you start realizing you have to take everything with a grain of salt and you have to understand exactly what they're talking about to really appreciate it. But this is how we find percent change. Okay? All right, thanks. I'll see you guys in class or in office hours.